For the third and final part of this series, we're going to go through and just find some of these examples and look at how to find the exact values of the inverse trig functions. I'm going to be referencing the unit circle a lot, so it'd be a good idea to have that handy. I'm going to go quickly and not really drag it out as much as I did in the other videos. So on the first one, cosine inverse of root 3 over 2. I'm asking what angle gives me this ratio? And when I'm asking that, I'm going to look here and say, okay, I'm looking for the angle in quadrant 1 because cosine is positive. So in quadrant 1, the angle that gives me root 3 over 2 for a cosine is going to be 30 degrees, or pi over 6, depending what I'm asked for. And that's as easy and as simple as I'm going to do it, just by looking at the unit circle. Second one, arc sine. Remember, this is the same thing as sine inverse of negative root 2 over 2. And if I'm looking at arc sine, that's negative. I'm going to be in quadrant 4. So who in quadrant 4 gives me negative root 2 over 2? And if I look at my unit circle, I'm going to find that this is, in fact, 315 degrees. Or I could write it as 7 pi over 4. Either way. Now, I do that by looking at the unit circle, and hopefully it goes quickly. This is my principal value. He's not the only one, not the only angle that has a sign that gives me negative root 2 over 2, but he's my principal value. Example 3, secant inverse of negative 2. Remember, secant is going to go with cosine. And I take my ratio, that's negative 2 over 1. And since we're dealing with reciprocals, I just flip it upside down. So it becomes 1/2. I'm going to keep the negative. So if I'm looking at cosine and I'm interested in a negative, then I'm looking at quadrant 2. So the cosine inverse of negative 1/2 in quadrant 2, who gives me a cosine of negative 1/2? It is going to be either 120 degrees or 2 pi over 3. Again, looking at the unit circle, not necessarily drawing reference triangles because I don't have to yet. When I hit example 4, this is where I have to draw a reference triangle because tangent's not going to be easily on my unit circle. At least we don't find him that easily from there. So I'm going to slow down a little for this one. If I'm finding a tangent inverse and he's negative, I'm looking at quadrant 4. So I'm asking what angle in quadrant 4 gives me this ratio of sides. So let me draw a picture. I'm going to draw the angle, which is there. But more specifically, I'm interested in his reference triangle. So in quadrant 4, I have opposite over adjacent. So opposite is negative 1, adjacent is root 3. Does that make sense with my signs? Yes, the root 3 is positive, and the negative y value is negative. So if I recognize this, I actually have a special triangle that's going to help me get my exact value of negative 1, 2, and root 3. So if I think back and think about who has the reference triangle where the 1 is across from the angle, and that's going to be a 30-degree reference triangle. So if that's 30, then my original angle was 330 in terms of finding who gives me that specific reference triangle. So if I'm going to answer my question, I want the 330 because I'm looking for quadrant 4 according to my picture right here. So I'm going to rewrite all of this. My answer is tangent inverse of negative 1 over root 3 equals 330 degrees. Or I could write it as 11 pi over 6. And again, I found that by looking at my reference triangle. I had to use the reference triangle because it wasn't easily identifiable on my unit circle. So that's how I'm going to do tangent. Use opposite, adjacent, draw my picture, and figure out who I'm looking at. Moving on to some calculators. We haven't looked at the calculator at all in terms of finding these. The calculator will always give you the principal value, so you don't have to worry about that. It will always give you the principal value. I'm going to get approximates because I'm no longer working off of special triangles. And I want degrees and radians. So you're going to have to flip back and forth on your calculator. And this is something you're just going to have to try as I go. But the first thing is you need to find the button that looks like tangent inverse. The tangent inverse button will probably be right above the tangent button if you hit second or something like that and then hit the tangent button. And when you plug it into your calculator, it should look exactly like this. tangent with the little -1, or tangent inverse of 0.47. Some of you, it might say arctan of 0.47. That's also another way of doing it. But when we evaluate this, given the calculator, I'm just going to give you what the values come out to, and we'll talk about do they make sense. If I look at degrees first, it's going to be 25.17 degrees, so make sure you can get that on your calculator, one way or another. And let's see if this makes sense. Tangent is positive in quadrant 1, and a 25.17 degree angle is in quadrant 1. So when I'm taking the inverse tangent, that's what I should get. And if I flip over to radians and evaluate it, I'm going to write that out. It ends up being 0.439. And I'm going to put RAD just so we can tell that that is radians. Normally I wouldn't put any sort of units after it. So I can check this. If I take the tangent of 25.17, it should end up as 0.47. Or if I take the tangent of 0.439, it should end up as 0.47. And you can go through and check that on your own. Second one, arc cosine. Remember, arc cosine is just a fancy way of saying cosine inverse of -√7. So we're going to just evaluate that on the calculator like we normally would. I'm thinking that it should end up as an angle in quadrant 2, somewhere between 90 and 180. So I go to take that arc cosine, and when I do, I'm going to run into a slight problem. Probably your calculator is going to say something like this, domain error. And we've seen that a bunch of times. We've come to know that really what that means is -√7 is not in the domain of the arc cosine. Or I could think about it this way. Supposedly this is giving me a ratio of sides. So I can never take the cosine of any angle and get √7 over 1, which makes sense because that would be saying that the adjacent side is √7 and the hypotenuse is 1. The adjacent side cannot be larger than the hypotenuse. So just be aware that I cannot take the arc cosine of any value. There are certain values in its domain that I can take, and we'll talk more about what that domain is. But for now, just be aware that you might hit domain errors or numbers that are not in the domain. And my last example here is an arc cosecant. Remember, I like dealing with sine a lot better. So I'm going to write it like this, sine inverse. I like that. Let me think. That's over 1. So I'm taking a reciprocal. It's really 1 over 2√2. I'm going to slap the negative there. So I'm really going to evaluate the sine inverse of -1 over 2√2, mostly because sine inverse is the only button I have on my calculator. So sine, negative. I'm looking down here at quadrant 4. My answer better be in quadrant 4 whenever I get it from the calculator. So when I plug this in, and not the easiest to plug in, make sure you put the whole bottom in a set of parentheses. For the degrees, it's -20.7. And again, I'm rounding these degrees, which makes sense. -20 degrees is in quadrant 4. It better be. If it's not, then I'm not getting my principal value, or something's wrong. I plugged something in incorrectly. And if I put that in radians, it's -0.36 radians, which also is in quadrant 4. So if I'm looking at my values using the calculator, I should get the principal value. I don't have to do any sort of work or any sort of fun or tricky trig. I just get my principal value out of it. And it should be in one of those correct quadrants based on our picture right here. Last thing I'm going to do is going to set us up for solving the trig equations. So if I look here, I have a very simple trig equation. It's saying cosine of x equals -1/2. So it's pretty much asking me to find the angle whose cosine is -1/2. That's the same question we looked at so many times. The angle whose cosine is -1/2. So I could write it like this. I could write it as cosine inverse of -1/2 equals x. I'm just rearranging the terms, and we're going to look next section at how do I take inverses and what does it do to my certain functions. But for right now, this is what I'm asking. Cosine inverse of negative 1/2 equals x. I'm looking for the exact value, which is my principal value. So if I have a negative cosine, the principal value is going to be in quadrant 2. So I just figure out who in quadrant 2, I can add that to my question, in quadrant 2, has a cosine of negative 1/2. I look at my unit circle, and this tells me that x, my missing angle, is going to be 120 degrees. Or I could write it as 2 pi over 3. So that's the principal answer to this little equation. In other words, the most basic answer that we can then build off of. And we'll do that in the next section. We'll take this answer and expand them by using ideas like coterminal and finding absolutely every angle ever that would give us a cosine of negative 1/2. But for right now, that's the value I'm looking for, is my principal value.